one.
Hey everyone, welcome back to the channel. Today I'm going to show you what tools I used in order to convert this G0704 into a CNC. But also, if this is your first time buying some type of mill, these are the tools that you're going to need in order to use it right out of the box. Enjoy. So you just bought a mill and you have no idea that you needed all these extra tools just to make this possible. So let me show you what type of tools you need in order to do this. And really just starting off with some basics. Any machine shop should probably already have these types of tools. And everything is, your standard run-of-the-mill type of items. But let's go into a little bit of detail so at least you understand what these tools do and how you use it, especially if you're trying to run this type of mill. So let's start out with the end mill. The end mill, 2-flute or even 4-flute end mills, are something cheap to pick up over at Harbor Freight. These are great because the quality is decent and it will cut anything that you throw at it. But the nice part is that they're cheap and very inexpensive. There was a lesson that I learned from Blondie Hacks, which was really nice, was buy a cheap set. And then as you're working through these cheap sets, see which ones you're using more often and upgrade them accordingly if you break them or cause any extensive damage to them. And that was really a good tip because you can start off cheap and have an assortment just like your drills, but at the same time, you have end mills that are very inexpensive, but you can upgrade them to higher quality end mills later on. I don't recommend spending a boatload of money just yet on a good, decent set of end mills because you are going to break these. Just understand that. You are going to break these. End mills take the most of the brunt of the forces from your cutting operations, so please don't waste your money on the big stuff yet. Take your time, understand your speeds and feeds, and go from there. Let's move on to the next one. So you have your end mills, but the machine really only comes with some type of drill chuck. And a G0704 has an R8 taper, and it comes with this keyed drill chuck. These are not intended to be used with an end mill. And the reason why is these are a press fit between the Jacobs chuck and the R8 collet. And this R8 collet is just a tapered fit. And any type of end mill, when it's spinning inside this Jacobs chuck, you'll realize real quick that the end mill itself is fluted and it wants to pull material away from the cut. What happens then, and if you can kind of see where I'm getting with, it will pull this Jacobs chuck, because of it only being a press fit, it will pull it out. So never use this type of tool with an end mill because of it being a slipped fit connection into this R8 collet. So in order to then end up holding your end mills, you're going to want to use some type of collet chuck. And this is just a cheap set of R8 collets that I purchased on eBay. And they come in various shapes and sizes. And normally you can get a pack of about 15 various sizes that end up matching the same diameters as all your end mills. Now mind you, just because an end mill is a certain diameter, sometimes it doesn't mean the shank that holds is the same diameter. So as you can see down on the lower end, the shank is quite large compared to the cutting head. So please just keep that in mind. Don't get too excessive with your R8 collets, especially if you're looking to upgrade this sooner or later in life to something like a TTS style system where it's a quick change, because then once you get the quick change, you'll only need one of these, and it's a precision ground R8 collet. So I didn't spend a lot of money, just enough in order to run the end mills that I own. And that's it. So you have your end mills and you have your collets. So let's talk about the vise. Now, I won't go into much detail because there's a bunch of videos that actually get these vices justice, especially how quality they are. But this is your standard run-of-the-mill eBay vise. Very inexpensive, nothing crazy about it. And I recommend you going over to This Old Tony. Check out his videos. He's got some really good details about how these vices are made, how they're constructed, especially when he tears it all the way down just to rebuild it all back together. So take a look at his videos and you can see from those how it's built. But also just take in mind this is a 4-inch vise on this mill, and you can see the travel will be limited because the vise sticks off the table. So please, if you get any type of larger vise whatsoever for your mill, just be cognizant that the mill is going to be limited in travel if you orientate your vise this direction, which is a standard orientation for these. So just keep that in mind. So let's talk about tramming bars. Tramming bars normally don't get the credit that they deserve. A tramming bar actually helps you align the head of your mill against the table. Aligning the mill is one thing in order to get clean, concise parts, but also when you're taking surface cuts and trying to finish, some type of piece of material, that's where you'll see a tramming head issue. Because when you move your head back and forth, left and right on the table, you'll realize if you're seeing any type of indentations or if you're seeing any type of lips off of a surface cut, then your mill isn't trammed properly. So picking up one of these is highly essential for running your mill, especially right out of the box. This would be one of the first tools that I would get if I was to be starting all over again. So let's talk about parallels. In order to hold your work perfectly parallel in your vise and leave it sticking off the top, you're going to need some type of offset. And that's where the parallel comes into play. A parallel is a perfectly ground, two surfaces, piece of steel that sits right into your vise, one on the front and one on the back. And you can put your material in there and clamp it down and hit it with a hammer or a dead blow hammer in order to get it to sit proper. Parallels are great because there's a bunch of different uses for these, but for the most part, what you'll be using is a parallel to keep your work completely flat and true to your head after you take your initial cut. So look at buying some parallels in order to do those operations correctly while you're doing milling operations. And then that leads me into the indicators. Indicators comes in many shapes and sizes, different types, and ultimately an indicator is great to clamp to any part of your mill, especially if it's got some type of magnetic base. These work, there's a spring-loaded rod in the center and it'll read whatever the indicator shows. But you should know that an indicator is just used to check items to make sure everything's running proper. But it's only going to be referenced off whatever surface it's clamped to. So keep that in mind. Clamping these in various different orientations will be needed in order to make sure especially that your ways are not shifting and might need to be tightened, or even the ways on the head, making sure that your tramming is proper. There is some bolts that go from the head into the back brace itself, and that's really to correct the orientation of it. But you want to use an indicator to see if you have any play, any slop, or anything of that nature. So picking up a cheaper set of indicators when you first start off is probably the best idea. And again, just like the end mills, Harbor Freight has these. And it's really good because they're inexpensive. You don't have to waste the money right now and then worry about breaking these. Trust me, I've broken a few of these already, and I'm happy that I went with the cheap ones first so I can learn how they're used and then go from there. Next up is we have a micrometer. Micrometers are precision tools that measure items. Some people are used to the regular dial indicator or some type of sliding indicator that uses for measuring, which those are great for a quick measurement, especially if you're just starting off. Picking up a cheap, dial indicator, sliding indicator, whatever you want to call those things, calipers, dial calipers. They're great and they work really well. If you're looking for precision though, picking up a set of micrometers, these are just reference blocks in order to check to make sure your micrometers are reading proper. And these are just like your parallels where they're precision ground, but there's a precision distance between these two, and they're labeled right here. So this one, for example, is a 2-inch. Use those to double check your micrometers, make sure everything is functioning properly. I don't have gauge blocks, so I'm happy that this comes with some type of gauge block where you can check to make sure that everything is up to par. But picking up some type of caliper, digital caliper, or some type of micrometer set, just make sure that you're getting the size in order to measure what you want. If it's not big enough, then you won't be able to measure it. So just keep that in mind. Next up on the list, drill bits. Again, a very cheap buy, something that gives you multiple drill bits, various sizes, is great because different operations require different size holes. Now again, I'm going to steal something from Blondie Hacks, but buying a set of cheap drill bits and using them accordingly and trying not to lose them, but upgrading them as you see fit. Drill bits are great because they cut mostly everything and anything, but don't spend your money on a very expensive drill bit set just yet. See what you're using more often and buy a quality set of drill bits after you've noticed what sizes you need. You can always buy them individually and upgrade your stock accordingly, and that's always the best way to do this. So buy some cheap drill bits because you're going to need them. And then that leads me into different types of fluids. For example, I have a big canister of WD-40, which is a great cutting lubricant, but also you're going to need some type of whey oil. And I always buy this in bulk and just fill up little containers because it's easier just to use what you need. You're going to need some whey oil and as well as some type of cutting fluid. Cutting fluids are great because they cool everything down as you're cutting them, and especially when you're doing a drilling operation because of its violence and, pulling material out, you want to keep everything lubricated. Another cool little purchase, and I've talked about this before in a prior video, is something like this, where it's a misting unit. Again, very inexpensive buy. I think I bought this one on eBay or Amazon, but just some type of unit where you can control your liquid and your air and basically just mist your parts as you're cutting them. This is nice because this mill is not set up to have flood coolant, and using a mister actually does just fine. So looking into cutting fluids, different types of fluids, whey oil. If you have any type of internal gearbox, you might need gear oil as well. But as of right now, for this mill, all you need is some type of whey oil. You'll need some WD-40. You'll probably need some cutting fluids. And while we're on the topic of different fluids, also look at different types of greases. I'm using a high temperature spindle grease actually for my ball screws, and the reason for this is it keeps a very nice thick paste and can be applied directly to the ball screws after I converted this. You'll see in a bunch of videos as well when you're doing spindle upgrades or any type of bearing upgrades, this is probably the best lubrication for bearings, and it's this Kluber lubrication Isoflex. And this stuff is great because you can use it low temperatures, and it's great for bearings, and especially for all the different bearing swaps that you have to do on this machine. It's just another good purchase. So look at different types of greases as well. Hopefully I haven't lost you yet, but next up on the list would be some form of boring bar. Boring bars are great because you can do larger diameter holes than what your drill bits would be able to do. And boring bars are great because, or boring head in this matter, is great because it takes a standard boring bar that you would use on a lathe. So these are great because eventually you'll probably end up reusing these on a lathe if you've purchased one of those as well. The thing about these though is you do have to make sure that they're ground properly. They're great because it's a piece of carbide on the tip, but unfortunately how they came ground, they don't actually function the best right out of the box. So if you are purchasing a cheap set of these, you probably will have to regrind this carbide tip and make sure that it's at the right angles to get you a proper cut. And while we're on the topic of making larger holes, you can use some type of caliper, digital caliper that I showed you earlier, or you can get one of these sets and this will measure your hole. These are spring loaded and the handle tightens up and you put it in your hole and you rotate it out. And then you'll take your micrometer and measure end to end, or also use your digital calipers to measure end to end, and that will tell you the perfect hole diameter that you just drilled. So again, boring head and how these work is very simple. You take your boring head and put it into one of those holes, and then you turn this with an Allen key and it'll slide it left and right down on these ways. So again, just another cool tool to have in your shop, just to make sure that you can do some larger holes. And while we're on the subject of that, getting some type of center drill. These are great because they're kind of multi-purpose, and I'll probably get nagged on in the comments about this, but center drills are great because you can use them to spot, and don't beat me up on that one. But again, it's one of those tools that's multi-versatile. You can use one of these, spot your drill, and then swap out to a regular drill bit and finish making your hole. These are also great because they can do the countersink operation for any type of, head that you need to countersink in because of the cut on the center drill. So picking up a set of these, they come in various sizes, but something that you'll also want in order to spot those holes. So you got this far. Now you need some type of way to locate your part on your machine. And there's multiple different things that you can use, and you can see my video about using this touch probe as a edge finder / center finder. But I also wanted to show you the manual ways that I've done it. My first ever part that I created was a edge finder, and the edge finder is just very simple: 2 screws onto a spring that's holding this. And I chucked it up into the spindle as far up as possible, bought a cheap set of parting tools, put it in the vise, and parted off just the little end here in order to make this. So looking at one of these, if you want to just make your own, they work just fine. Just measure the outside diameter and take half of it, and whenever you line it up, it will, work as an edge finder. Another cool little edge finder that I found online that was fairly inexpensive was one of these digital ones. They do take a special type of battery, but I ended up just throwing a AA battery into it. And again, it uses the same technology where once you've touched off a part, by moving this head slightly, a little light comes on. And all it's using is a metallic part. So if you only have metal and you're trying to find the edge of a metal part, this is great because it will detect it. If your part's not metal that you're machining, this will not work. So keep that in mind. And then finally, if you've done the conversion into a CNC like I have, you can see my video about the touch probe itself, but how this works is just a simple mechanism on the inside that no matter what it touches off of, it will basically tell the machine, hey, I found something, I ran into something. So any one of these 3 will work. If you're just starting off, I would definitely just look at making your own because it's a fun little project and something that's super simple to do. And continuing the theme of this video, material. This, for example, is aluminum, and it's great, it works, and I actually bought this online at an online metals supplier because where I live, unfortunately, getting material is kind of hard to come by. There is a shop that's not too far away, but far enough away where it's an inconvenience. So look at online metal sales. There's some great prices, especially for smaller parts. Obviously, if you buy bigger, it's cheaper, but at the same time, are you really needing it? So look at purchasing material itself that you're going to mill or cut or make into any shape, size, or whatever your heart's content. So look at materials and understand that if you don't have easily accessible materials near you, then look up online and there's some great deals, especially drop parts, cut parts, different types of bargains that you can do. And again, search around for material. You'd be surprised that your local hardware store or big box store doesn't have a lot of material that you can use on your machine. And most of the time, that material is junk. So anything thicker than 1/8 of an inch probably won't be at your big box store. So look various places to purchase any type of material. Next up, tap and die set. Something that you're going to need if you want to thread some holes and you don't have a lathe to single point thread, or maybe you just are like me and have a mill for right now, and this is the only thing that you can use in order to make threads. Just like the drill bit set, purchase a cheap set and work your way up from there. If you end up breaking more and more taps because of them being very cheap, start looking at more expensive taps, more expensive dies, and swap out your kit accordingly. As you can see, I already broke a few different taps in my collection, but just keep that in mind. You can always buy replacements individually and higher quality, especially if you're noticing that you're utilizing a tap more and more and more. And some good old hammers as well. Look at something inexpensive, something with a brass head and maybe a nylon head, in order to not mar your material. When we say mar, meaning you're not going to damage and put an indentation in any of your material while you're trying to set it in the vise and get it parallel. So getting some type of double head type of hammer as well as a dead blow hammer should be in your arsenal of tools in order to run a mill. And last, but certainly not least, education materials. You'll want to see some type of book that, like in this case, the Engineering Black Book. You'll want some type of reference for items that you're doing. Different types of speeds and feeds, surface finishes, cutting, threads, any type of drill sizes for your threads. This book has it all. And for a machinist, having some type of quick reference is great. If you have any of these electronically on your computer, sometimes you don't have access, or maybe you can't search it fast enough as if you could flip through a book. So buying some type of educational reference material is key in order to make this successful for you. Especially some other types of material, reading materials, so you can understand what's happening, or maybe understanding some type of information if you don't have all the knowledge that it takes to use this book. Buying something that can explain it a little bit more in detail is where you need to start. They also sell the Machinist Handbook, which is the Bible, and it is a very thick book, and it kind of is a little overwhelming to someone just starting off. So look at some type of reference books, or maybe some type of hobby books or model books in order to get the understanding. I actually specifically bought this book just to figure out O-rings, and then this book just to make sure that I had the right drill size for the tap that I was using. Again, these are all inside the thicker book of the Machinist Handbook, but it's a little bit cumbersome to flip through thousands and thousands of pages in order to find that information. So these are smaller books, cheaper books, but look into some type of educational material just to keep you running your machine at top-notch quality and cutting speeds and feeds, or even assembly or geometric dimensioning and tolerancing of your parts in order to make sure that everything works perfect. So I want to thank you for watching. Appreciate you going through that journey with me, and hopefully this video helped you out. If it was me and I was purchasing or trying to convert some type of mill like this one, I would look at the more expensive options first because of all the different parts you will need just to start converting this machine. Now, mind you, you do need these tools for any type of operations, but if you're just starting off and you want to make a conversion to your machine into a CNC, you're going to need all those parts first in order to make that conversion. If you purchased a CNC that was a little bit more quality or better machine, then you can slowly purchase your parts as you're trying to make that. And the nice part with the CNC is a lot of these tools go away because the machine will just be able to do it. So keep that in mind if you're looking to convert or build a CNC in general. Keep that in mind if you're trying to get into this as a hobby like myself. And yeah, that's it. So thanks for watching. Greatly appreciate it. And if you don't mind, if you want to leave a comment for a future video, please do so. As well as like and subscribe if you feel like this type of information is useful for you. So thanks again, greatly appreciate it, and have a good one.